The challenge of any organization is how to maintain its dynamisms, how we can evolve and very quickly build the future. I think the danger of any organization is to be stuck in the past. I think we need to respect the past and build the future. Hopefully, this is what CIAT is all about. What's really interesting about CIAT is innovation was always part of our DNA. If you look at our history that John mentioned today, we looked at a lot of innovation in a research component, in an organizational component, in our relationship and partnership component. So what I'm hoping to do today is like take one subset about how we are going to build the future, looking at one specific technology. To do that, I'm going to go back to the past. I'm going to go 51 years ago, and then it will be my only slide about the history, and then move forward. So if you look exactly 51 years ago, the Green Revolution started. In fact, ERI and CIAT and other partners celebrated last year the development of IR8. It was, following Borlaug example at CIMMYT, it was one of the major achievements in terms of agriculture research. The developed IR8 created a huge benefit for the subcontinent and also for Latin America. And Peter Jennings, who incidentally started his career at ICA before ERI was established, before CIAT was established, working with Fedar Rose here in Palmyra, brought very quickly IR8 to Latin America and created the whole revolution that we benefit all of us, from Argentina, Uruguay to Mexico. In fact, there is still an IR8 variety in Mexico still grown right now. So this was one of the kind of innovation coming from breeding. So what are the CIAT breeders have been doing and how they can maintain their dynamisms and always looking for the future. CIAT breeding objectives are somehow well defined, but we have evolved over the time. Initially it was yield and pest diseases, but over the years we have strengthened and using kind of creative strategic thinking, incorporated several new areas of our investment. Creating new end product. Waxy cassava was not in any strategic planning. It was one of the major achievements more recently. Meeting consumer expectation in terms of the quality of the grains, the quality of our forage, and developing more nutritious crops. I think we heard from Ruben, we heard it from the president about the impact of high iron, high zinc beans, and also the achievement of provitamin A cassava. So the objectives of the breeding program have been always evolving. The question have been always kind of incorporating new innovation in our breeding system. And over the years, we had several milestones. I'm not to go to all of them. In fact, it was a subset of what we have achieved in the past. But from the beginning, the CIAT breeders have tapped into the diversity. We established the double haploid in rice very quickly and integrated with the rice breeding program, and several of the people who did it are here. We had a very elegant programs on recurrent selection, but in the context of apomictic and sexual. There is very few programs that have incorporated recurrent selection in an apomictic and sexual system, as in the case of brachiaria. We have incorporated markers and genome sequencing within our breeding program. More recently, Steve Beebe has been able to achieve major adaptation to acid salt in tapping into coccineus, Phaseolus coccineus, in a way using major impact on very complex traits. We have also kind of used several structure population and developed hybrid rice, and more recently we have engaged in genomic selection in rice, which are now used extensively in the private sector for wheat and for maize. So CIAT breeding program has evolved, has incorporated innovation across the years. Now, the challenge forward, and this is a kind of landmark article coming from University of Minnesota, but the infographics are coming from CCAF here at CIAT, is that if we look at the trend, and this is, I encourage you to read this article by Ray, I think it was 2013 or 2014, about the global production needs for the next decades. And it's really evident that we need to double the yield production if we want to kind of ensure that we are not encroaching on new land production. This is a case for like 4 crops, but you can extend it to multiple crops, especially CIAT crops. So a big challenge, how we are going to use our strengths in the past to build our future. So in the case of CIAT, we are looking at multiple strategies that are parallel and well integrated. Some are related to how we are closing the yield gap in terms of by kind of enhancing our agronomical practices. FLAR has been leading this effort. How we are going to reduce post-harvest losses, how we are going to protect yield gain. In multiple countries, due to climate change, we are seeing a kind of shift in pests and diseases, how we are going to anticipate these kind of pests and diseases, and how we are going to integrate precision phenotyping with our breeding. At the same time, how we are going to accelerate genetic gain using multiple strategies in breeding. And the team here at CIAT and across SCG has been kind of using novel breeding strategies. I think CIMMYT has been leading the way for maize and wheat in terms of genomic selection. CIAT and CIRAD has been leading the use of genomic selection in case of rice. And how we are going to integrate our sequencing and bioinformatics and big data with our breeding. And obviously there's other areas, but one area is related to genome editing. Now, who here has an Economist or National Geographic subscription? Okay. So if we look at genome editing, it has been in the press in the last couple of years. It's really a revolutionary tool in the case of human and also in plants on how we can modify genome regions with very targeted high precision. What's really interesting about this technology, and this is different from different technologies in the past, it was initiated in 2012, but look what happened since 2014. And this is a subset of covers of scientific magazines and also kind of popular magazines. This was on Economist, National Geographic, but obviously there is the technical part in terms of Science and Nature and PNS and other kind of technical meetings. And the revolution is continuing. It's like maybe one of the most exciting area on human biology right now. It's most probably one of the most kind of promising technology in terms of agriculture. So what are we doing at CIAT? We team with several leading organizations. NARU in Japan was one of them since 2014. And we start initiating several activities, how we can accelerate the breeding using genome editing. Right now, we have 3 major projects on the 3 crops. Some are related to gene function, some are related to diseases, some are related to waxy cassava that I will explain, and some are related to nutrition quality and digestibility. I'm going to go through very quickly through a series of examples. Through a collaboration with Stanford and the University of Iowa, we are already kind of knocking several genes for disease resistance in case of rice. We have quite advanced. In the case of beans, we had a major breakthrough this year in terms of the transformation system that is needed for genome editing. At the same time, we are targeting 2 key genes related to antinutritive compounds. So again, how we are going to use this kind of technology for a very specific purpose. Some will be on the area of nutrition, some will be area on climate change, some will be the areas on productivity, disease resistance. In the case of waxy, we have been quite successful of identifying a natural mutant and incorporate it with our breeding program. However, the breeding of cassava is very complex and take time. And we feel that using genome editing on a waxy gene will be able to speed up the development of new varieties across different regions. Our strategy is similar to what the Pioneer has achieved recently by using a natural variation of waxy in maize, but using genome editing to develop and accelerate the specific product of waxy maize in different countries. In fact, it was already approved in the States as non-GM and also in Argentina. One area that is not related to breeding, but is going to facilitate breeding, is the whole area of using genomic editing, CRISPR-Cas13, for diagnostics. This is an area that's expanding. It started, in fact, this year. We already established collaboration with MIT Broad Institute, where the technology was developed. And hopefully, this kind of allow us to provide a kind of a quick, fast, cheap alert system across the globe for several diseases that will guide our breeding program, at the same time allow us to respond to different climate change methods. So our breeders have been kind of incorporating at least the discussion of genome editing as part of their strategy. We are also engaging with the research community in Colombia and across Latin America. This year alone, we have established several events. We started December last year with the first training course in Colombia on genome editing, where we had around maybe 25 participants ranging from the industry to the academias, from the agriculture sectors, regulators, and students. We did a very interesting symposium funded by Pioneer a couple of weeks ago, where we brought experts from Cornell, from Pioneer, from Benson Hill, small companies in St. Louis, from Merck, from NARO, and from CIAT, to discuss and also kind of provide the overall strategy. So as a group, again, I think what we have been doing is that tapping in new innovation, how we are going to accelerate the genetic gain, how we are going to incorporate new tools for our purpose. Right now, we feel that we have a kind of a good genome editing platform that will be an opportunity for partnerships. But at the end of the day, we strongly feel that the genome editing is an additional tool for breeding innovation. If you look at the history of the breeders and the breeding, it was always about innovation. You start from the maize at Pioneer with the hybrids to the more recent using sophisticated big data from sequencing and environmental trials to accelerate genetic gain. So again, genome editing hopefully will be part of our breeding innovation and will be an additional tool to speed up our crops. Now, we're talking about our history. I tried to go and look at the list of our breeders over 50 years. I haven't been at CIAT for 50 years, but I know several of them. And what's really interesting, some of them were extremely stubborn, but there is common characteristic across all of them is a kind of this dedication for innovation and to deliver a product. So with that, I'll stop. Thank you.
So we'd like to welcome Rob Bertram and Eduardo Trigo up to the stage to participate in a dialogue with Joe.
It's up to you. I can be in.
Okay.
So we'll try and keep this to about 15 or 20 minutes. The ground rules are keep it lively. What I'd like to do is ask both Rob and Eduardo to open up with just a couple of comments and maybe end with a key question for Joe. Please.
I thought it was that picture, Joe, that you showed of all the breeding innovations and how at the forefront of these kinds of really important enabling tools CIAT has been. It was a very good introduction to this next new and very exciting opportunity through CRISPR-Cas. I guess I can say a little bit about how we're thinking about this as a donor interested in funding research for development. Clearly, it's an opportunity to unlock more from the diversity we have. So CIAT, in a sense, having so much diversity that it conserves, I think can use this tool, and you already pointed out some examples that I hadn't realized. I hadn't realized that you're already delivering products based on this kind of of either being able to silence or change a specific sequence. As I understand it, CRISPR-Cas does focus on homologous sequences. So that's a lot of opportunity. There's a lot of sequences that match up. However, some of the really important things that we also are benefiting from in agriculture are not about homologous sequences. I think the literature's people pretty much agree that we will be editing whole genes pretty soon and probably be able to move away or beyond the limitation of just having a homologous sequence. But in the meantime, there are some very important innovations out there, for example, things like Bacillus thuringiensis, that are going to remain very important. So I guess one comment would be that, this doesn't, at least in the short term or medium term, eliminate some very important other breeding techniques and biotechnology applications. And it's not just BT. You could think about, for example, drought tolerance, where you're using bacterial genes and such. So, and then that's going to raise some very interesting questions as we do move towards being able to edit whole genes, and possibly to the point that they're not substantially different from a transgenic, because they are quite novel. And I guess what this brings us to is this whole issue of regulatory, because I think that's the big question mark that's out there in terms of how the world is going to either embrace or possibly limit the use of this new application. And I think this is a work in progress. I suspect Joe knows a lot more about this than I do. But there are, I think, what we're hoping for from the perspective of AID is to really foster a science-based approach to regulatory. And I think generally this means looking more at the product than the process. But this has been very controversial, as I think we all know, in the context of transgenics. And I think there's a real globally held perception that as we look at this new type of technology, we should learn from how we handled the transgenics. We need to do a better job of public education. We need to do a better job of explaining that this particular approach is actually not very different in very substantial ways from the natural evolution that occurs or from mutagenesis. I find that most people aren't really aware about the extent to which mutagenesis has been used and not regulated for decades and decades. So it's a little tricky sometimes discussing that with a non-scientific audience. But I think we've clearly got a challenge there around doing a better job of helping people understand this and hopefully driving acceptance and hence better use. And of course, the last point, I guess, is that this means coming up with really compelling technologies. When you talk about a scientific tool absent a concrete example that really delivers value addition for farmers, it quickly becomes an academic discussion. It becomes one where if somebody wants to take a non-scientific position, they can do so without really annoying anyone, except maybe a scientist, and that's not the group we're trying to win over here. So I guess one question for Joe is Joe, how do you see this evolving on that front, and what are the most exciting opportunities from your perspective around targets and products that will help inform and hopefully in a positive way drive the acceptance of these new approaches?
So Joe, how about if we hear from Eduardo, and then you can answer both questions at once.
Well, okay. Well, Rob took one of my issues away, which was I think that this the introduction to this is that Science has done it again, in a sense, because it has offered the opportunity of really big jumps in technological opportunities. I mean, these technologies, I mean, if you put these technologies in a 50-year perspective, or maybe a little longer, I mean, 50 years ago, we were thinking about plants and animals just as they, pretty much the same way that they have been for, what, 3 billion years. And now we are discussing sort of a completely different ballgame in terms of what we can do with them and what we can intervene, do for them to do whatever we want. And that means a fantastic opportunity, I mean, because it's not only agriculture, it's horizontal, really. It touches every single aspect of our life. And I think that when we talk about the next 50 years in CIAT or in any other research center of this nature, I think that what we are discussing now, gives us a hint that it's going to have nothing to do with what we have witnessed in the past. The frontiers are no longer there. That's the science part of it. So the big issue is how do we avoid to make the same mistakes that we've done with the earlier generations of this new knowledge. Because if we think that the potential of the new knowledge that started back in the 50s, its limitations were not really on the science, has been on the institutions and the technology delivery mechanisms and the mess we have done with those processes. And we have been, how we have failed in really getting the most out of it. When we look at the GMOs as, well, not the only, but maybe the most prominent example, really it's so narrow, the exploitation of the potential has been so narrow that in front of the challenges that it's really shame. And when you analyze a little bit, it's nothing but institutional failure that have led us there. So you took away the main question. I think we are on the, and I'm going to risk an answer on that. I think we are on the right track because at least we have not started, by regulating. We have started by saying we are not going to regulate. And there are a number of countries that have already gone ahead and started to put products in the market without regulation. And then there is the growing common sense that how do we regulate something that, as Rob very well described, it's not very different from something we've been doing for a long time and not regulating. And again, how would we know what would regulate if we cannot distinguish what's been intervened from what has not been intervened? So there is a whole practical issue. So I think that we are on, but we should not be content with that. I mean, we should be very careful and make the proper steps to make sure that that trend continues. Now, having said that, my concerns and my questions or my comments would go in the direction of two issues that have not been discussed much here, although there has been a lot of discussion and a lot of interchange about the collaboration. I mean, there is an issue that, the field, the institutional structure, and I think that Phil, I don't know where is he, yesterday talked a little bit about that. There has been very important macro changes in agricultural research structure, who's funding the private sector, all the issues. But there is another issue that's been, and it's more linked to the molecular biology, is that molecular biology, it's not in the agricultural institutes, it's in the universities. I mean, that's a fact. I mean, when you look at the publications records, I mean, that's very evident. I mean, it's not, the capacities to do this, to handle these technologies are not in the traditional partners of the CGR. They are in the university, in the academics. And that's one issue, and it's a big issue because academics is not used. Well, first of all, universities, at least in Latin America, and I think in other parts of the world the same, are not the best equipped institutions to interact with the private sector and the productive sectors. Usually they have a lot of limitations. They have got better, but the public-private issue at university level, at least in Latin America, it's not an easy one to handle. That's one. But then we need to create a new sort of institutional environment to move on these technologies, because that's where the country's capacities are in these new fields. But then, to finish, I want to call attention to something else that, and this has not been discussed in the last 2 years. It's in the technology delivery mechanisms, the seed systems, to make it short. One of the problems, and I think that there's a recent paper by someone from ISPRI, for David Spielman, I guess, is showing that we are not doing much, we are not improving much in the seed business. I mean, rotation, germplasm rotation, it's not improving. Actually, it's in some cases, it's been going down. So if except for the large multinational companies, the sort of the national systems are not evolving into being an active mechanisms to take the research results into the fields, we do have a problem, a big one. And these technologies would make the problem even bigger in political terms, because since they are cheaper to implement, they mean an incredibly important opportunity for smaller local companies to jump into the business. But we don't have that infrastructure on which, that platform from which to build up. And I think that that's an issue that we cannot ignore, and probably it's part of the sustainable food systems approach that Ruben was taking.
I agree with what Rob and Eduardo mentioned. I just want to make comments and answer the questions. We're kind of in a very exciting time in terms of science. We're seeing this kind of nexus between kind of the genome data, environmental data, big data kind of merging into one area. The challenge is how we're going to use it to address this kind of the negative trend. If we go back to the article from University of Minnesota, how we're going to, in the next couple of decades, make sure that we'll be able to maintain yield in par with the population growth in the context of climate change, and then providing specific products that the society is requiring. What's going to require? It's going to require kind of integration and use of multiple tools. Some tools will be still biotech trait. I will not talk about the need of BT, which is essential for certain crops like cowpea, but I'll talk about nutrition trait. Right now, in case of rice, we haven't been able to identify the adequate level of iron in rice. However, through overexpression of a rice gene, we are able to do it, and it's part of a big project with Harvest Plus, Erie, and CIAT and University of Melbourne, with some funding from USAID and also from the Gates Foundation. So overexpression will never, at least as of today, cannot be addressed with genome editing. So the biotech trait will be really needed, and iron is one example. The second is that what are kind of regulatory status? I think right now, at least in Latin America, Argentina and Chile are quite advanced. They have a policy maybe similar to the United States. If it's kind of knockout of a gene, it will be non-regulated as a GM. Colombia had recently a meeting of their regulators at CIAT as a closed session. And I think they're kind of also preparing their regulatory framework that most probably will be similar to Argentina, which is also similar to the USDA system. What are the challenges? I think the challenges is identifying the right traits. Again, to learn from the experience of the past. In our case, in the case of beans, we are looking at traits that will have a major impact in digestibility and also anti-nutritive compound. So this will be a consumer trait rather than a kind of production trait. This is one aspect. The second is that it's going to be requiring the whole area of communication. I think we failed in multiple areas when we are dealing about technology to convey the kind of the right message to the society at large. In the case of genome editing CRISPR, I think it's a bigger challenge because now it's in the press on a regular basis. It's one of the major breakthroughs in human genetics. So it's going to be more visible than when we start talking about the GM. So hopefully there is a communication strategy, there is kind of harmonization of policies and regulatory frameworks across several regions. It seems that here I dare to say that Latin America can take the lead as a region. I think Chile, Argentina, and most probably Colombia, and I think there is also kind of discussion with Brazil. These 4 countries can really make a big difference in kind of the international discussion about the regulatory framework. Finally, it's like the relationship between the different sectors. And here, I think genome editing is going to require a kind of a special attention between the research organization and academia than before. So the ENIAs and the CG centers and even the private companies will have to team with the different universities in the region. And finally, I think the delivery mechanisms is maybe one of the biggest challenge. I think seed system is maybe one of the weakest kind of piece in the context of any breeding program, and especially in kind of innovation breeding, like in case of using genome editing. So these are some kind of quick observation.
So I just want to interject here a little bit because this last point I think is actually really critical, and it talks about the social systems side of this. As a director of Ag Bio, who are you engaging in CIAT to help make sure that we have a value chain, if you will, from the improvements that you're working on all the way through to a sustainable seed system, through to a seed system that actually meets the consumer demand for these otherwise kind of productivity-oriented activities?
Now, I want to remind the audience that the technology was kind of more visible in 2012. It started picking pace in 2014. So what we have been doing in the last maybe 3 years, we have been working especially on the technical part. We have tapped into our existing infrastructure and expertise with the superb team that we have here in Colombia to develop at least the proof of concept. Second, we have linked with major partners in the public and the private sector. I'm not going to go through the list, but it's an extensive list. And we have conducting several workshops bringing different actors from academia's seed sectors and also private sector. What's still missing is this kind of dialogue about the future and how it's going to be used in the context. So communication is going to be really key. I think we have started some discussion with the International Seed Association. We are engaged in some of their meetings. We are engaged with several regulators to explain the technology. But internally, I think we'll have maybe a couple of areas where we need to kind of implement as quickly as possible. One is the prioritization of the traits that will be relevant for farmers and consumers. I think we don't want to fall into the trap of the technology-driven versus kind of what are needed at the different levels with our stakeholders. So this is the prioritization is going to be really important. Is this gene more important than that gene? In what context? In what environment?
And have you been working with the ex-ante economists?
No, this is what I'm saying that we should be doing. The second is that we need to kind of establish a communication strategy with our partners. I think it will be kind of very, I think, strategic from the beginning to have a communication strategy with our partners. We're in discussion with multiple partners in the regions, especially in Latin America. So how to establish a communication strategy to explain the technology, explain what we want to achieve, and then what's needed. And third, I think especially in areas of I would say, foresight, we can make a prioritization in existing trade, but there is existing trade that might not be considered 5 years from now, 10 years from now. So what are kind of the trades? So.
Fantastic. So since we're all familiar and comfortable with the academic literature, I'm going to, as a closing, I'm going to ask you to do something very, very simple. I'm going to ask each of you for your 3 key words that would describe where we're at with this, where we need to go, however you'd like to couch it, but your 3 key words. If you were to type up the title to the summary of this talk and had to attach 3 key words to that, what would it be for you, Rob? What would those 3 be?
Maybe one, Maybe one is leapfrog. And that's because Joe mentioned, he talked about waxy cassava, and he said, well, you know, you could breed it, but it'd be really hard, because it's hard to breed cassava. Well, it's hard to breed quite a few crops that haven't had the kind of investment that rice, wheat, and maize have had, or even beans.
So leapfrog.
So leapfrog, that's one. A second one would be maybe leverage, and that would be about Eduardo mentioned the universities, but I'm also thinking about the private sector. And, you know, in the transgenics, the private sector, because it was so challenging in terms of all the regulatory and the costs, they basically dominate. But here, if this is a different regulatory landscape, maybe there's room for more players. So interesting about where the private sector is, but also, you know, how many hundreds of flowers are going to bloom. That was more than a word.
So leapfrog, leverage. Do you have another one with an L?
I don't know that I have another one word.
Perfect. Eduardo. Well, how about seed systems? I think that would be key.
No, I think I'll go with the last of Rob's idea, which I think it's the big important. I think the big change, the big innovation here, it's on the economics of innovation, if you wish. Because really we are talking about the major turn down in the cost of getting major innovations into the field. I mean, if both in time and in actual cost. I mean, regulatory biotech before could go forever or 10 years. I mean, it was not unheard of. Here we have a technology that is effective, that is focused, and that you can do what you want in a fairly short time, in a relatively simple way. I don't know how you do it, but yesterday was mentioned that you could do it at your farm. Someone mentioned it yesterday, I don't recall. The DNA and do the CRISPR-Cas at your farm. I don't know if you can ever, if we really think that as possible today, but then that would, if that is really going to evolve, if we make sure that that evolves, that this opportunity evolves in this direction, potential direction, we may be in front of a major change in the structure of the system.
Fantastic. Quick comment from Rob, and then...
It's the third word.
Third word.
Doesn't begin with an L.
Oh.
Diversification. And the reason I say that, it builds on the leapfrog idea. In that other room I was in with the other donors this morning, people are talking about, you know, the interest in diversifying the diets and nutrition. And one of the challenges has always been that we don't have ways to necessarily target smaller crops without a huge investment that might not be commensurate. But if we have shortcuts along the lines that Joe talked about, maybe this is a way to make significant changes in commodities for which very little attention has been paid.
So in reality, leapfrogging again, but from a different standpoint. Joe, a final word or two, and then we'll wrap it up.
Okay, I think my 3 words will be integration with multiple breeding strategies, with kind of this revolution in informatics and bioinformatics and genome sequencing that hopefully will lead to better prioritization. The second one is acceleration. I think hopefully this technology integrated with the breeding innovations that are already happening in the different programs will accelerate the delivery of product. And finally, I would say engagement. I think engagement at different levels, at the technical, at the kind of the more general public regulators will be really essential for the success.
Fantastic. Let's thank our guests, and let's thank Joe.